Welcome to this Landwise presentation on efficient irrigation for irrigation operators and crop managers. So why is irrigation efficiency important? What are we trying to achieve? Improved irrigation efficiency means that we get more crop per litre, which also means we get more crop per production dollar. Better system performance means we use water more efficiently as well as energy. And better irrigation management means that we are using correct scheduling and we have minimum environmental impact. Sustainable irrigation indicators can be broken into three groups: economic indicators, environmental indicators, and social indicators. Economic indicators are those on farm: the crop production from the water used, the profit per volume of water used, the energy used, of course, to pump the water in the first place, and any labour that was used for the irrigated crops. Environmental indicators include: was the water effectively used per volume taken? What were the effects of any abstraction? Did we have an impact on the ecosystems and streams, or did we reduce groundwater levels? And of course, what is the chemical or nutrient leaching impact? Social indicators look at the community benefit from an increased production. Largely, what was the dollar value returned back to that economy? But also, was there a loss in amenity? Did we see a decline in recreational spaces or landscape? When we talk about irrigation efficiency, there could be many different ideas of what that actually means for different people. So understanding what it is that you're actually trying to find out or measure is really important. We're going to talk about a couple of terms now that are often referred to as irrigation efficiency, but it's really useful to define them before you continue on in any sort of efficient irrigation assessment. So application efficiency is how much the applied water was actually used by the plant, i.e. how much went to waste. System capacity is the ability of a system to actually meet the peak demand or the peak evapotranspiration. Return interval is how quickly can our travelling irrigator, for example, get from paddock A to paddock C, hopefully fast enough that that crop doesn't ever end up at stress point. Water use efficiency is a commonly debated term, but in this context we're going to refer to it as being water used per unit of farm output. Hydraulic efficiency is about our pipe work. What is the pressure loss between our pump and headworks all the way through our main line to the outlet or the sprinkler? Energy efficiency is about looking at the power consumption. Did we use a lot more power than required because we have a really big pump, or could we potentially have done something better with our system to reduce that energy load? Again, the efficiency measure that you're using depends on what you want to know. We just defined application efficiency as being how much water was stored in the root zone and therefore used by the plants and how much went to waste. So to calculate that, we take the water stored in the root zone by millimetres divided by the total water applied in millimetres. This is a really important measure because we're over applying water, we're allowing for leaching. We're allowing that water to move below the root zone and move through into our groundwater. If we're not applying enough water, then our plants are getting into stress faster and we're having to reduce our return times to make sure we get back to that paddock and apply water in a timely manner. So what are the main irrigation inefficiencies? This table is actually really interesting because some of the most emotive things that we see happening on farm that people tend to get really upset about are actually not a big deal. It's the things that we can't see by eye that are largely the problem. So let's break it down. Leaking pipes has a range of about 0 to 10%, but typically we don't have many leaking pipes, so we have a really low loss component. Evaporation in the air, this has been found to be only about 3% as a typical loss. Wind blowing water off target. We've all seen this. Someone set up the travelling gun or the boom and the water's just been blasted away. In those situations we do see a high amount of drift and loss, but typically it's about 5%. The canopy of course intercepts some water and will evaporate off the leaf. And of course surface water runoff is never something that we want to see because it tends to take away some of our topsoils as well and our nutrients. However, one of the worst parts about irrigation inefficiencies is uneven application or distribution uniformity and excessive application depths and rates. This is where we can see a range of somewhere between 5 to 80% inefficient water use and typically between 5 or 30%. As I said at the start, these typically can't be seen by the eye, but we can see the other things and we get really emotive about them. But actually getting these other things right, even water application and managing our water so that we're applying what we need when we need it, that's where we can see some of our biggest gains. American A.J. Clemens produced this table on system types and their attainable application efficiencies in the 90s, and it's still relevant for today. In the vegetable production systems in New Zealand, it's typical to find fixed boom irrigators, travelling guns, centre pivots and linears. We can see from this table that centre pivots and linears have a very similar profile and are able to produce some of the highest application efficiencies. Fixed booms can meet the similar specifications as pivots and linears, however they are starting to decrease, and travelling guns, while they can perform okay, are at risk, with some of them only able to produce 60% efficiencies. In the mid-2000s, A.J. Clemens' work was built on in a New Zealand context. Testing was undertaken on irrigation systems in Hawke's Bay, Canterbury and Marlborough. The test results of those systems are highlighted by the stars. That shows what the application efficiencies were for the systems that were tested. The green stars show where systems were originally tested and what their initial performance was. Maintenance was then undertaken on those systems, and the blue stars show that after maintenance, system performance improved, and by how much. This really highlights the importance of testing our systems and undertaking maintenance to ensure that we can continue to keep those systems at their application efficiencies as by design.